on how to develop impactful and educational notebooks. So today's short course will be more on a bit technical, and I hope that we can share some of our experiences developing Jupyter notebooks in the past 4 years, specifically for an educational and training context. And we will also share some experiences on how you can make your notebooks more usable and user-friendly in case you share notebooks also with collaborators or within your team or also for others. So this work, my name is Julia Wagemann. I'm supporting EUMETSAT on behalf of MIO with training on atmospheric composition data for the past 4 years. And this work is together with Sabrina Cito, Simone Mantovani, and also Federico Firli from EUMETSAT. So just a short background on myself. So my background is in Earth observation, remote sensing, and climate sciences, and I've started using Jupyter notebooks already in 2014, so almost a decade long. I've been using Jupyter notebooks in order to develop workflows, data analysis workflows, and also sharing these workflows on GitHub. And specifically for the past 4 years or 5 years, I develop also Jupyter notebooks in an educational and training context. And as a result, we have developed more than 120 educational notebooks on open Earth observation data, and also that give an idea on how to handle access and visualize Earth observation and large volumes of atmospheric composition and climate data. The trainings I've been involved in are range from short webinars, like a webinar as we have today, like from 1 to 1.5 hours, but also up to week-long intensive training schools. And we also developed notebooks for more online courses, which on massive open online courses that took place in the past years. I also developed notebooks for this. So I'd like to that in the past 4 years, and I specifically also did some more in-depth research on Jupyter notebooks in the past year. And so particularities of Earth observation data education, what we observed in the past years, if we compare Earth observation education also with academia or other training courses. And so what we particularly observed is that in our trainings, we have limited time because especially with an instructor. And so we often also have limited time. So for example, for a short course, we don't have enough time to set up the programming environment. So, so this is one particularity. The second particularity is also that we often work with a diverse training audience, and diversity is reflected with regards to experience in handling Earth observation data. So it can be from beginners to also already Earth observation data experts, but also diversity in experience working with programming languages and experience in the knowledge how Earth observation data can be applied for different applications. So we also face quite a diverse and wide variety of different training audience in our trainings. And then we also found or made the experience that we have to offer a flexibility of how the content can be taught. So specifically after COVID, we all came to online training or on default, right? But so we also needed to develop training that gives us flexibility that can be taught online, but also at the same time on site. And in the best case, because we are limited in our trainings, in our instructor and face-to-face training. So in the best case, the training material, what we develop, can be used with an instructor, but at the same time also can be understood without an instructor. And so, as I said, like I did a bit of more in-depth research in the past years on Jupyter notebooks, and I'd like to share some of the findings with you today. And so, Jupyter notebooks, they became we can say the default notebook on how to share and develop data science workflows in the past 10 years. And by today, or there is a paper, I also linked these papers here below. There's a paper on 2018 and again one on 2021 in Nature, who explain more on who is using Jupyter, and the paper on 2021 even identified Jupyter notebooks as one of the 10 computer codes that transformed science. And both of these papers, they stated like there's a sheer amount of notebooks available on GitHub. So it's more than 10 million at the time of 2021. And probably by now we even have more Jupyter notebooks available on GitHub. So yeah, as I said, within 10 years, we can say that Jupyter became the de facto standard for data exploration, analysis, and training. And mostly notebooks are used for research experimentation, development, also for machine learning pipelines. But important also, there's a high percentage of the area where notebooks is used is also education. And for this, we need we have to also make the notebooks educational so that they are understandable and it also can easily be followed. And so with this, in my research, I had a closer look on how are the notebooks, or how do these notebooks, these 10 million Jupyter notebooks on GitHub, how do they look like? Are they ready for to be used in an educational context? And so there are some pitfalls and some challenges, as you can probably imagine. And I'd like to share with some of these pitfalls and what the reality of Jupyter notebooks looks like with you today now. So the first one is that the biggest challenge, or people who are not a big fan of Jupyter notebooks say why they don't like notebooks is that they foster poor coding practices, because we can execute notebooks or the different coding cells in a notebook out of order. So and there is a specific code, a specific presentation, which I recommend you also to have a look on, of JupyterCon 2018 from Grus, and he specifically said, I don't like notebooks, and he features quite of the some of the pitfalls why he doesn't like notebooks. And one of them is that they foster poor coding practices. So that basically we can start at the beginning with a code cell, then we develop our workflow, and then we execute a cell, but we see, oh, we forgot to define a variable, then we can jump again on top, we can execute a cell. And so basically it's often probably also a reality of everyone who develops notebooks, that you often jump from top to bottom within a notebook quite regularly while you develop the workflow. The second one is regarding challenges to make notebooks reproducible and reusable. And for this, I invite you to go to slido.com and enter the hashtag EUMETSAT, so EUM-SC39, or you can also scan the QR code, because I have some two poll questions. Before I share with you some of the research I found, I would like to ask also the estimate of the course participants today. And then I also ask Rosa to share her screen and the poll results. Okay, so the first question I want to ask you is, how many notebooks do you think can be, of these 10 million notebooks hosted on GitHub can be executed. And there's the options around 75%, more than 75%, around half, 50%, or less than 25%. So we see already that participants today, they're not very optimistic. So you say, like, the majority at the moment, 47% say that you expect less than 25% can be executed. Okay, so we just wait a bit longer. Maybe it's getting a bit more optimistic. Okay, 50% still, 36%. Okay. Okay, so around 70% or 80% say that around you expect 50% or even less than 25%. Okay, interesting. Okay, so then we have another question. So the second question we have is how many notebooks hosted on GitHub do you think are in fact reproducible? So that you can execute a notebook and you will also get the same result as the author of the notebook. And the options, they're a bit lower because probably we speak here of reproducibility, so it's always even more challenging than just executing a notebook. But yeah, so we see, okay, some are very, very optimistic that like more than 50% also reproduce the same results, but the majority so far, 31% say less than 10%. Actually, of the notebooks hosted on GitHub also show the same results in the end. Okay, good. So then let's see what the research shows, because there. So I will stop your screen, Rosa. Thank you. And I go back to sharing my screen. Okay, so so now I would like, so there's a specific study from Pimentel et al. In 2019, and they in fact analyzed all the notebooks on GitHub and seeing and trying to see how if they could reproduce the notebooks and if they could also execute the notebooks. And so regarding execution, there was exactly 25%. So 1 out of 4 notebooks on GitHub could be executed. So only 25% of these 10 million notebooks. And regarding reproducibility, the majority of the course participants today were also right. So only 4%. So really less than 10% also produce the same results. So even though we have this grand amount of notebooks available, there are challenges to make notebooks reproducible and reusable. A third pitfall is that annotations, and these I always linked the studies where I found this information here below, so you can later on you can also have a look at these publications as well. So a third challenge, quite some articles found or some research projects found, is that annotations are not evenly distributed with a notebook. So even though notebooks say that, or it's never been easier to follow the scientific and literate programming paradigm, so to really combine code, text, description to what your code is doing, it's never been easier. But you see in the notebooks that are hosted on GitHub that they usually start very well at the beginning. And then towards the end, you just have one code cell after the other. And you also often have empty code cells in between and also right at the end. So there is often not a cleanup process of the notebook that are shared on GitHub. So there's a lot of text at the beginning and then hardly text at the end. And often there's also quite a few notebooks that resemble more a collection of loose scripts than a narrative. And a lot of notebooks, they have far more code cells than descriptive text. So And so these findings, they brought us then to, or the general Jupyter community brought the community to define and also to identify the need that we need best practices for the community on how to write and share Jupyter notebooks, how to make notebooks reproducible, how to foster collaboration, and also how to use notebooks in different settings, among others, for example, academic classrooms. And there are already quite a few papers out there who developed and defined best practices on different aspects with working with Jupyter notebooks. And I also linked them all here. So feel free to also have a look at them. And so based on these best practices on different aspects on writing and sharing Jupyter notebooks, to make them reproducible, to foster collaboration, we defined 5 guiding principles specifically if we use Jupyter notebooks in a data science context, but also specifically in a data context where we train users of data how to use the data. And so more for a data science education and capacity building context. Important is that these principles we defined, they are founded in recognized best practices already defined in fields of scientific computing and also Jupyter notebook research. So we didn't reinvent the wheel. It was just that we, as I said, we reviewed also already existing best practices and then defined specifically 5 guiding principles where we say, okay, they're specifically applicable and important if we are in an educational and capacity building training concept. And these 5 guiding principles I would like to share with you now. Just before I start, I just would like to give you a background how we came to develop this quite a few notebooks, and also how these guiding principles came to life and in what context they also have been applied. So in 2019, we started for EUMETSAT to develop a training course with the aim to improve the use and uptake specifically of atmospheric composition data. And so the data is quite diverse because they come from different satellites and from different models. And so the idea was to develop simple recipes to show how the data, how they can load the data with different formats, how they can, if needed, manipulate data, and then also how they can visualize the data. And so the result is a training course with over 70 notebooks related with different modules on data access, data discovery, case studies, and also exercises. And because what I shared at the beginning, we also needed to cater for different literacies regarding programming, Python knowledge, data knowledge. We also developed a collection of 14 reusable functions that help us for effective visualization and data handling. And this functions, or this collection of functions, this helps us in our trainings to cater for different Python expertise and different levels on Python and coding. And I will show you also how this can be implemented and looks like. So overall, you see here a more graphical representation of the course. So we have here these different modules. Important as well that we invested quite some resources on it to make the notebooks, because it's over 70 notebooks, to also help users so we guide them through a specific sequence on notebooks, and we to help them to get also an overview of what notebooks are existing. We developed a specific index notebook, which is kind of a landing page or a starting page for the content or for the training content, and the functions library which makes use of well-known Python libraries for Earth observation and multidimensional array data. Array data use is used for all of the notebooks on data discovery, case studies, and exercises. And then, because we use this content also in different setups for trainings, and we try to be reproducible, so the training content is being made available via dedicated Jupyter Hub-based training platform, which can be accessed via ltpy.atomplatform.eu. And the entire content is also available on a GitLab repository where the content can be also cloned and then reproduced on local machines. So since 2019, we ran more than 41 training events, and more than 2,000 learners participated in these training events and used these notebooks. So the first guiding principle is to leverage the literate programming paradigm. And what does this mean? So the literate programming paradigm is nothing, so probably first give an overview of the 5 different guiding principles. The first one is to leverage the literate programming paradigm. The second one is to use instructional design elements. The third one is to follow best practices for scientific computing. The fourth one is to take advantage of the full Jupyter ecosystem. And the fifth one is to aim for reproducibility. And so I will now go through them step by step, but I just also want to let you know that these guiding principles, they also have been published in a paper, which I linked here below. And if you want to get a bit more details on why we came to these 5 guiding principles, then feel free to have a look at the paper. So the first principle is to leverage the literate programming paradigm. And for this, the idea of a literate programming paradigm is not new. It was already proposed in 1984 to make the idea that code can't exist alone, and it always has to come with a descriptive information what the code is doing, and by adding a description to and an explanation of the code, it really also improves the value of the code, because then it becomes more useful for more and for a wider community. So the idea is not new, but just since Jupyter notebooks and the notebooks came to life, it was the first time where it was also very easy to actually implement it. But the reality looks like that, as I said, like there are two studies who analyzed if the literate programming paradigm is implemented also in notebooks, and one is by Rule et al., and they analyzed more than 1 million notebooks, and they found out that 1 out of 4 notebooks from these 1 million, they had no text at all. It was just code. So the literate programming paradigm is not fulfilled by 25% of the notebooks that are shared on notebooks. And then there's another study from Quaranta et al., and they analyzed more than 1,000 notebooks, and they specifically analyzed the text code ratio, so the number of text cells versus the number of code cells in these notebooks, and they saw that the median text code ratio is 0.4. So we have by far more code cells than descriptive text in the notebooks. So we, as part of our study last year, and also as part of the paper which we published, we also analyzed the notebooks of the LTPY training course and also built the ratio between text and code cells. And you see here on the different modules on data access, data exploration, case studies, and exercises, you see here the total number of cells, then the number of markdown cells versus the number of code cells. And then we build a ratio. And we see here that, like, in average, our notebooks had 3 times more text cells than code cells. But we also developed our notebook specifically for an educational context. And so we also added additional resources to make the notebooks also available, that they can be followed in a self-paced manner, and that they also understandable without additional context from a teacher. But so our recommendation is in general for all the notebooks that are hosted on GitHub, that someone wants to share with the outside world, we need to put an additional effort in to make notebooks more understandable and more descriptive. And this means we also have to add more text and descriptive text to notebooks. And a recommendation is that an useful or educational notebook should have at least twice as many text cells compared to code cells. The second guiding principle is to use instructional design elements, and this is specifically to help users guide or to help them and guide them through individual notebooks, and if you have a collection of different notebooks, to also help them to guide them through different notebooks. And I will just, after the presentation, I will also show you some of these instructional design elements right in a notebook. So the design elements we make use of are alert boxes, which we see here on top. So with these alert boxes, we can color codes or markdown cells in different colors, in red, blue, orange, and green. And with these boxes, we can just specifically highlight important text or additional text in just make it differently, and it also at the same time improves the usability and user friendliness and experience of the notebook. Then there's also we often combine Markdown with HTML code, and so there's also in the notebooks in the LTPY training we implemented a navigation pane, and so this navigation pane helps users or training participants to navigate seamlessly from one notebook to the other. So if they open a notebook in Jupyter Lab, for example, then they have a direct link also on top and also on bottom to the notebook we recommend that shall be followed in the next step. And at the same time, also users have the opportunity to go back to the index notebook at any time. And another feature or instructional design element we make use of is that we often also highlight specific text we want to highlight, not only as bold, but also we highlight it as code. And so there is also just like a simple command that you can highlight a text in a different way. So you can highlight it as a code, and then it is in the background it is gray. And then another very useful design element which we make use of is to help users also guide users within a notebook, because specifically if you have often long workflows of data analysis, because you have multiple different steps, you first have to load the data, then you have to explain how you have to manipulate the data, and then you also have maybe some complex data analysis, so you can have sometimes quite long workflows. And so it helps to develop an outline to first give an overview of what this workflow of different sequences or chapters the workflow has. And then you also give an opportunity to directly jump to a specific sequence of the notebook. If, let's say, someone knows already the first parts and they're specifically interested in how to visualize the data, then you also help the users directly jump to different parts and sections of the workflow. And in the practical section, I will also show you how you can easily implement anchor links to develop this. The third best practice is to follow best practices for scientific computing. I think this is a general recommendation, but I think it's also important to repeat this, that we really have to put this additional effort in, especially if when notebooks are used in an educational context, because then you also have to see it as that your notebooks set are a role model or set a specific example on how things should be done. And so, but at the same time, so because the first recommendation is to modularize code. So in scientific computing, the recommendation is to modularize code as much as possible. There's in the training context, you always have to set a compromise. But I will also show you how which compromise we found. And I already mentioned this before. We outsourced some code functions or some code which we saw that we reuse it all over again, specifically for visualizing the data. So we outsourced this code into a separate notebook. It can also be outsourced into a separate Python file. And then we load this notebook or this Python file right at the beginning after we loaded our packages. And I will show you also then how you can easily open the docstring of the functions you defined in this notebook. And this helps also then training participants to apply these functions. And so this is one way how you can modularize code, and you can still then load code content from a different Python script or notebook into another notebook. Then another general recommendation is to import libraries right at the beginning of a workflow. So you often also see it in notebooks hosted on GitHub that libraries are imported all over the place. So when we share notebooks, then we also should follow that we import libraries right at the beginning. Important also to apply and use a consistent code style and also formatting of the code, and to use meaningful names for variables. And this is even more important if we use notebooks in an educational context, because in the end, your notebooks and workflow has to be understood. The fourth guiding principle is to not only rely on Jupyter notebooks, but really take advantage of the full project Jupyter ecosystem, specifically in an educational context, because there is great tools out that make the content, or that allow to make the content available in different ways. And specifically, I think quite often notebooks are hosted on GitHub or on GitLab. And even though GitHub offers a built-in rendering tool, it's often not nice. And so what we recommend is, for example, for static sharing of the notebooks, you can use NB Viewer, for example. So this is what we use as when we want to share a static content of our notebooks, but not only also share it as a static content, but also as an executable content. In our case, we have the luxury to have funding for a Jupyter Hub server that we can run and maintain a dedicated training platform. But even though there is no additional resources for a specific Jupyter Hub server, there's also free tools out there that allow you to make content available. So, for example, you can make an executable version available via Binder, or also via Colab and Kaggle. You can upload notebooks, and then you can share a link to an executable notebook via Colab and Kaggle. And then the fifth and last guiding principle is to aim for reproducibility. And here we specifically only set aim for reproducibility, because we're also aware that it is a big task and a big aim to be reproducible. The research on notebooks showed it. So far, only 4% out of these 10 million notebooks on GitHub are reproducible. And often our experience also trying to make notebooks as reproducible as possible. It is going the extra mile. And so with this guiding principle, we would like just to invite everyone and motivate everyone to more often go the extra mile, because it greatly increases the usability of notebooks. And in particular, it is even in particular relevant when notebooks are used in an educational context, because if the notebooks are not reproducible or not executable, then it is an additional stumbling stone and bottleneck for the training experience, and this can also often more lead into frustration than to additional motivation to actually continue with the training and learning process. But at the same time, we are also aware that reproducibility is not, it contains a lot of aspects. It is because, especially if we work with large volumes of data, it includes making data available for the training, making instructions, instructions available for how you can reproduce your Python environment also on a local machine. And this includes also that you specifically have to specify under which package versions and under which Python versions and which dependencies your code ran. So this is already quite a bit of work. And at the same time, what could already help is to make notebooks easier, and to also identify some of the bottlenecks that are in your notebooks. If you, before you push them to notebook or before you share them, if you try to execute your notebook from top to bottom, so that it's like just the best practice also for yourself before you make your content available, just run your notebook from top to bottom once, and there is quite a high chance that probably most of your notebooks they fail to run from top to bottom at the first time. And so with this, you can already eliminate some of the bottlenecks, and just to do a bit of cleaning before you push it. So remove empty code cells, bring your Python code package imports right at the beginning. So just some basic cleaning will also already greatly increase the usability of your notebooks. And yeah, with this, I would like to stop on the theoretical introduction, and also to give you just an overview of these guiding principles. And I would now go to a practical session, just like, yeah, another 10 minutes, just to show you how this looks in practice, how you can include some of the instructional design elements, or also how this works, or how we work with our code modularization. And for this, I just jump over. I already opened a, so it's on our training platform here, in fact, and I just developed a notebook on some of the instructional design elements to show you how this looks in practice. So here, so like most of you probably are aware that we have like coding cells and markdown cells, and with most cases you can use the simple integrated markdown, and with markdown you can create titles. So this is a title, a major heading. Then we can also create subtitles. Sorry, maybe let's open this here again. Then so we can just remove, and we can convert it to a markdown cell. And if we want to have subtitles, then we just use different multiple numbers of hashtags. And this is a subheading. And then, so like the first I would like to showcase you is how you can do these alert boxes. And so this is now the rendered version, but in principle, it is a simple HTML div tag and a specific class, which is a alert block. And the class you have to define is class alert, and then alert block, and then alert warning. And so with here after alert, you can specify a different name. And so warning is for an orange box. If we change it here to success, then it turns into a green box. If we change it to danger, then it becomes a red box. And so there's a total of 4 boxes, which I set up here. And so we started with warning, I think, yes. So warning is an orange box, then a green box is success. So then we have here alert success. Red is alert danger, and info turns into a blue box. And yeah, so these boxes we use also to help, like in our training context, just as an example, how we use these alert boxes. At the beginning, we help people because it's quite a long training course going through 70 notebooks. And so in each notebook at the beginning, we use an alert box, so like a colored cell, where we tell them, okay, you are under this module, for example, for data discovery, and we recommend you to go through these and these notebooks before you go through this respective notebooks. Or we also highlight specific notebooks that can be used or can be followed as a follow-up. If a notebook is on a specific data type, for example, and we created a case study where this data type is also used, then we also link in this specific alert box also to additional content on this data. But also for exercises, we use alert boxes and say then like what the exercise is. So this helps just to bring a bit more variety into the notebook, and at the same time also to make the notebook more enjoyable to browse through. Then the next step is here code highlighting, and here we just have to set these marks at the beginning. So like to the right facing marks at the beginning and at the end. And if you set these, then automatically the text that is within these marks is highlighted as code. The way we use or implement this code highlighting is often specifically if we talk about variables. So if we explain in our code what a specific variable is doing or what a specific function is doing, then we highlight that we talk now here about something related to code. And so then it's also easier for the trainees to identify what we talk about. And at the same time, it also helps to provide additional diversity to the text. So it's not only black and white and a long text cell or a long text block. So as part of the best practices there, as I said, we developed a functions notebook, which I also made available here. And so how the functions notebook looks like is that at the beginning, we also give an overview of all the functions that are available. So you see that at the beginning, we have some notebooks on data loading and reshaping functions. And because the training we developed, as I said, we used 6 different satellite data and 5 different model data sets, and they all had a different format. And so we often needed to rearrange the data in a way that we can then also work with it and to bring it into. So our overall aim with all the data to bring it into a multi-dimensional X-array data structure, because as soon as we had the data into an X-array, into a multi-dimensional array structure, then we could apply also additional functions on visualizing, but we were much more flexible to handle and manipulate the data. And then we also had a set of visualization functions. The function we mostly use for yeah, I would say quite a high percentage of the data sets. For not all we can apply it, but for probably 80% is visualize p-color mesh. And the way we develop this function, so we combine here matplotlib functionalities with cartopy features, and we made the function as agnostic as possible, that we can apply it to most of the data the course introduces to trainees. And so this function notebooks, it basically consists of first a heading. So we here also applied the code, highlighting, but it is at the same time also a heading. And then we define the function. And important here to also foster good coding practices, that we also added a docstring information. So a docstring for a function is that explains you first what a function is doing, and it also gives you an overview on the required parameters the function has to set in order to operate. Then this is important, because once we just remove this one, because now I go back, because and so like because this docstring is important, because this allows us now to also load this information in another notebook. So let's say, so we have this functions notebook, and we want to now call this functions notebook in our data workflow. So let's imagine this notebook here is our data workflow. Then we can use here %run command, and we can point to the functions notebook, and then we can run it. And once it is run, we can, all the content we have as part of our functions notebook is now available also in our notebook here. And the way how we can see it is that we can, for example, open the docstring, which we defined for each of the functions, with question mark and then the name of the function. And so if I run this, then the same information what we provided here as docstring is shown in the other notebook. And this is helpful because they are predefined functions for the training course, and even though we apply them quite often, specifically learners, if they use it the first time, it's helpful to know which keyword arguments we have to set in order to make this function work. And so this is quite a nice way to outsource some of the content that is replicated quite often, and especially code, if we work with a data visualization in a data visualization context, then you might also often replicate the same code for visualizing data or subsetting data or something like this. And so this could be one way to outsource some repetitions and some of the code that is repeated quite often. Good. So yeah, at the beginning, and then like another best practice is also to import libraries at the beginning. So a best practice is, this is not actually a good practice, because this is right at the end. So in the best case, it should not be at the end, but what I wanted to showcase here is to bring all the Python packages that are used in one workflow in one code cell and directly import it at the beginning of the workflow. And this gives also users and learners a good overview of which packages are used in or are needed in the workflow. Okay, and the last example I want to showcase you is the anchor links. And so here I just started. So what another aspect I would want to highlight is important is also for workflows to really help learners and users to break different aspects into as many sub-steps as possible or also as needed. So this means we often work with horizontal lines to differentiate between, for example, here the intro part with the with the part where the workflow starts. So horizontal rules and are also very useful, and you can just use these brackets and define HR, and then you can add as many horizontal rules as you wish. And then here these anchor links. The idea is here that we want to create now for all the headings, we have here some a module outline at the beginning. And so I started already with the headings, alert boxes, and code highlights. But let's just do it step by step again, because then it's easier to follow. So let's say we want to create for alert boxes and code highlighting 2 anchor links, so that you can directly also jump to the part code highlighting and also at the end to import libraries at the beginning. So I first start with a bullet point and then square brackets, alert boxes, and then I add here a hashtag, and I can define the name of a specific hashtag which I want to use then later on. And so I just change this here and I call it alert. And then I do the same. Let's do for here import libraries at the beginning. And so I beginning in square brackets, and I call the hashtag import. Okay, so if we do something here and we click on it, nothing will happen, because now we have to add our hashtags, which we defined here. We have to add them as an ID to the respective heading where we want to have the anchor link set. And so our alert boxes are here. And so I just remove this again. So how you do it? So usually you define a heading. So we have it here with these 2 hashtags. We have a subheading. And now I want to link it to our first link here on top. And as a reminder, the hashtag for the first one is alert. And so I add here, no, sorry, again, A, and then I set an ID for the specific heading, and I use as the ID alert. And then I also close again the A. And with this, I made a connection to this anchor link here on top. And so if I click now on the alert box, it directly jumps to this section of my workflow. And the same we can now also do with import libraries at the beginning. So we have to go to the title. We have to set here again A and then ID equals ID, and we called it import. And then I also close it again. And so now we also set again the link. If we now want to jump directly to this aspect, then we are directly jumping to this part of the workflow. Yeah, so I think this was for now a short overview of some of the principles we apply when we develop Jupyter notebooks, specifically in a training education context, specifically for Earth observation data. But we also believe that most of these guiding principles can be applied for any kind of use for notebooks. And our intention and aim is also just that we want to improve the statistics that are the statistics of notebooks, that in general notebooks will be better executable, will be also more reproducible, because in the end this will also help then the community, that overall all the notebooks that are available on GitHub and that are out there overall are also more reusable and also more enjoyable to use. And with this, I'd like to stop now and also open the floor for any questions if there are any. So you can go again to Slido, and we can go through some of the questions. Okay, so the first, I see one question, if we can share the paper link in the chat or later. So probably, I believe we have all the information to all the registered attendees today. So we can also share the paper because I don't have the direct link of the paper now in the chat. But no, actually, I can get it quite quickly. 1 moment, then we have it here, and then I share it in the chat. So I believe that you see. I'm not sure if let's see if I paste it, if you can see it. Or maybe Rosa has to paste it to the training participants. Okay, so I shared it in the chat, and yeah, and Rosa also reshared it. So now you should have access to it. And then the next question is, can the courses you mentioned be accessed by students? Yes, definitely. So we deliberately, or we specifically also developed it for students, and probably at the end, or like after the end of the short course, for all those who are registered, we just send you some of the links I shared with you, and also the access to the slides. And then you have all the access details of the training course, the notebooks, and the paper, and also the slides which we shared today. Then the next question, EUMETSAT SMA training had Jupyter Notebook library with ready codes for ocean application. How can I download the codes from the online repository? Yeah, so there are different notebooks available. So we, as I said, like this is for ocean applications, and in general, or in principle, a training code is hosted, or training code from EUMETSAT is hosted on GitLab. And there should be instructions on how you can also replicate the same environment on your local machine. But if it's hosted on GitLab, you can also just use git clone and then the repository name, and then you can easily copy paste it, or a local copy is then provided on your workstation. So git clone, and if you go to the link of the repository, you should see a button which says clone, and then you get the address which you have to add to your git clone command in order to clone the content on your workstation. Yeah, the next question is if I experienced Jupyter Lite that allows to run Jupyter Lab fully in the browser without Jupyter Hub server. I attended JupyterCon just 2 or 3 weeks ago, and this was a big announcement during the JupyterCon conference. I haven't tested it out, but this is one of the top points I took from the conference to try it out. But it's, at least in the presentation, it seems very, very powerful. But I can't give any experience on this because I haven't tried it yet. But this is really something new. And if you're into Jupyter, then I recommend you that you should try it out. Okay, so then the next question is, I use Colab. Could you show or share an example of good practices using this tool? So Colab is actually the same as Jupyter Notebooks. So it's just in a different platform, and it's online for free, and you can just access it. And so the same principles that I showed you that we use for Jupyter Notebooks, you can also add to Colab. So you can make use of design of Markdown and HTML to add colored boxes. You can use the anchor links. So there shouldn't be any big differences, because in the end, the content or the interface you work with in Colab is also a notebook. So you can apply the same guiding principles also to Colab. Yeah, of course, I can show you LTPY on the fly. Sure. For this, I will just share my screen again, and I just have a look on the other question before I share my screen. Do you have some tips, resources, examples to share about the storytelling with Jupyter Notebook? So in particular, in the domain of remote sensing. Yeah, so probably So probably one example could be that you have a look on the LTPY notebooks. Not sure if we have if it fulfills the full standard of storytelling, but at least it is a start, because we developed some training contents where we started to really put remote sensing also into a context. So we started, for example, for wildfires, we first introduced them to a specific wildfire event, explained also or linked to specific news articles about a wildfire event. And then we broke it down step by step to see how different Earth observation or satellite data can be used to analyze the same wildfire event, for example. So yeah, as I said, like on the training course page, we also can link some of the examples. And when I share my code, I also show you two resources we developed specifically for wildfire and dust monitoring, because there are Jupyter books. So we developed Jupyter notebooks and bundled them into two specific thematic application Jupyter books. But for this, I just share my screen and I show you how this looks. So basically, the LTPY you can open with the LTPY platform, and you can follow ltpy.atomplatform.eu. And I just hope that the server is up now, because we had some challenges yesterday, but it seems working. But probably you will come to an interface where you first have to log in and create an account. And so if you don't have an account, then you will be redirected to the following, so to this site. And so it's now a bit slow to span, so probably it's my internet. Okay, while this is loading, I also open.
We are not seeing your screen, Julia.
Okay, sorry. Thank you, Rosa. Okay, sorry. Just put this here. Okay, so what I said is like, so you, in order to open the LTPY notebooks on the Jupyter Hub platform, you have to go to ltpy.atomplatform.eu. And then a Jupyter Hub server starts, but it is quite slow at the moment. So usually it's faster, but it could be also my internet, because I'm not in Europe at the moment. But let's see if this is spanning up. But at the same time, so if you log in or if you follow the website for the first time, you not directly come to this to the Jupyter Hub, but you will be redirected to the login interface. And so for this, if I log out, you will be asked to create an account, and this is quite easy. So you can go to sign up a new account. You will get an email, and you have to just accept accept the email and the registration. And then you have your username and password. And once you are logged in, you can then, you will come to an interface like this. And then you see different platforms, and then you can follow here the first link on the left, which allows you to access directly the LTPY platform. So the LTPY platform hosts continuously the learning tool for Python training material, and this is also not changing. So this is statically there, and you can work with it and go through the notebooks. And this is exactly the I just closed these notebooks here. Yeah, it doesn't matter. So basically here you see the modules on data access, data exploration, case studies, exercises, and each folder you see then different notebooks. And it's just a bit slow at the moment. And then there's also other platforms. So the middle one we specifically use for dedicated training events. So for example, we have an upcoming training school in September, and for these training schools, which are a week long, we use a dedicated training platform. And this platform you can also log in, but this is up to frequent changes. And then the two other resources I would like to share is here the Jupyter book on fire and also on dust monitoring. And so these are notebooks for data, for Earth observation data on wildfire monitoring. And we bundle these notebooks into a Jupyter book. So if you go to fire.trainhub.eumetsat.int, and this is where we started a bit of storytelling. So we wanted to give an experience that users specifically on this course learn about the entire fire life cycle, from which data can be used before the fires come, so to identify potential fire risk. Then also when the fires appear during the fire, which data can be used, and also afterwards, which data can be used to assess any damage. And so there are two case studies which you can have a look that allow to go through different notebooks and data. So one is on California in the US in 2020. And so it introduces you to different data sets, but at the same time, first it introduces you to a case event. So it sets the scene and gives you background information, and then also an overall information why this data is specifically of use for this specific context in the wildfire life cycle monitoring. And similar to this, we also developed a Jupyter book on dust aerosol detection, monitoring, and forecasting. And here as well, so you can go to dust.trainhub.eumetsat.int. It first gives you a short introduction, also what the course is about and also why it is important. So we also give a background on dust monitoring with satellite images and also other data, so including ground-based and also model data. And then the course is structured that it gives you an overview of quite a high variety on remote sensing, satellite data that can be used for dust monitoring on different processing levels. So satellite data, level 1 data, then level 2 and also level 3 products, but also ground-based information. For each of the sections, we also give you here general information. Okay, what is it actually? So what do we measure with ground-based information, and why is it important, and which data networks exist in order to measure dust and aerosols on the ground. And so for each chapter, we have an introduction session which introduces you theoretical to the content, and then a practical subsection on different data. And then each part we introduce you first to the data set itself, and then we developed a workflow that guides you step by step through different steps in order to retrieve the data and then also visualize the data. And so this is for observations, similarly for remote sensing satellite data, but also ground-based information, but also forecast models. So we give an introduction to forecast models, and then we introduce you to 3 different forecast data that you can use to monitor dust. So I don't want to claim that this is like the best standard. This is just one option how you can bring additional context with a storytelling hint to all this with Jupyter notebooks and Earth observation data analysis. And yeah, as I said, these information we will provide on the course site, and you can go back to the course site and you will have then a full list of all the material and papers I shared with you today. Okay, so I have some, so there's one comment that you tried out the notebooks, but you didn't succeed because you couldn't import some modules. So there's probably a difference. So it's a good hint because of course each system also has to be maintained. And as I said, we had yesterday quite a challenge with some of our Jupyter Hub service, but they are now up and running again, but it's a good feedback. So I will definitely make sure that on the platform, everything should run. If it's on your local working station, then it could be that some of the Python packages are missing. But this is for me now hard to assess, but I definitely make sure to have a look on the Dust and Fire platforms that all the notebooks are running, and I will verify it specifically because we had a challenge yesterday. So yeah, with this, I think we are already, I also don't want to take much more time because we're already 12 minutes over the actual time. I thank you all for joining, and please also go or stay on Slido. We opened also a feedback questionnaire. It's just a couple of questions, but we would be really interested in how you like the course, if this type of course is interesting, and also if you on what other topics and ideas of courses you're interested in. So this helps us also to tailor our short course offerings to what you're all interested in. And with this, I say thank you and goodbye, and wish you all a nice evening, afternoon, or day. Thank you.